Chapter 2 is basically talking about the cause of rotation. In chapter 1, we learned about the rotation. We learned about the motion of an object on a circular path or rotating. Right now, we will talk about why and how you can start an object into rotation, or how can you stop the rotation of an object. So basically, basic idea of this chapter is this. So now, before starting the chapter, we are going to define in two things. One of them is point mass. The other one is extended object. What does point mass mean? What does extended object mean? We are going to try to get this. So you studied this case in the 11th grade. No, in the book, because point mass and extended object is not very clearly explained. That's why I am going to give some examples from 11th grade. And think that there is a block on a frictionless surface. So this block, this object, is I locate on the surface. The surface has no friction, as last year. You did so many questions like this. And I choose 5 different points on this object, 5 at different points. So one point in here, other point is in here, other one is in here, in here. You can choose more points, but I choose only 5 of them. So if I release this object, so let's release this object. See that this point, every point is moving in the same direction, correct? Every point on this object is moving in the same direction. Correct or not?
Yes, you're right.
Yes.
What about their speeds? Is the same?
They should be.
They should be, of course. They are starting at the same time. They are at the same place at the same time. I mean, which means their speeds are the same. Even directions are the same. Yeah, in general, I can say that. Every point on this block, when it is sliding on an inclined plane, is moving with the same velocity. With the same velocity. Their velocities are the same when they are moving. These are the same. And so then, which means instead of studying all the points on this object, studying only one point can give the information about the motion of all other points on this object. So I'm going to describe the motion of a single point, and this information, this motion will give an information about the object, every point on this object. So, as you see in here, I choose only one point. I choose the center of the mass. If I define the motion of center of mass, which means, in fact, I am defining the motion of the object as a whole. Every point on the object is moving with the same velocity of the center of mass of this object. So that's why describing the motion of a single point, which is the center of mass, describes the motion of the block as a whole. Then, in fact, I just studied the one point, motion of one point. I didn't study the object as a huge object, just one point. So this is in physics, is explained as or described as block is traded as a point mass. Yani you traded this block just like a single point, because wherever this single point goes, object is going that direction. So physics says that, yes, in this case, we are trading this object as a point mass, because studying the motion of one point, in fact, is giving about information about the object as a whole. And the motion of the center of mass, or if motion of the center of an object is described, that motion is named as translational motion in physics. You studied translation motion last year. All those motions, which can be along a line, straight line, it can be a parabolic path, or it can be, we have studied this year, a circular path. In all these types of motion, they all call translational motion, because you are studying the motion of center of an object. And three words defining the translational motion of an object. If you study translational motion of an object, then you must treat this object as a point mass. If you are studying the translational motion of an object, you have to treat the object as a point mass. Like this. 3 words: revolve, orbit, travel. When these 3 words are written in a sentence, this sentence is defining the object as a point mass, or you should treat the object as a point mass. Like what? For example, one sentence: Earth revolve around the sun. So it is defining the translational motion, and we only concentrate the path followed by the Earth's center. We only concentrate the path followed by Earth's center. That's why revolving is referring translational motion. So Earth in here must be treated as a point mass. But moon here, moon orbits Earth. Of course, you are defining the motion of center of mass of the moon. So in here, orbiting the Earth, as moon is orbiting the Earth, you are defining the motion of center of mass. That's why moon must be treated as a point mass in here. Or a car travels around a circular path. You are defining the motion of center of mass of the car. So then in here also, this car must be treated as a point mass. That's why we say that these sentences revolve with a sentence with revolve, a sentence with orbiting, a sentence with travels. These all they define the translational motion. That's why all these objects must be treated as a point masses, no matter how huge they are. We don't care. And of course, this is what point mass. When we should treat an object as a point mass. Of course, we have to define one more thing: extended object. So sometimes, in some cases, you have to treat an object as an extended object when, assume it's a disk, and this disk is rotating about its center. This is the axis of rotation. So as this is rotating, I choose different points on this disk. One point in here, another point in here, another point in here. You can choose hundreds of points, billions of points, but every point in here is moving in different directions, correct or not? According to tangential speed, yes. Every point on this object is moving in different directions. Even they have different speeds. That's why you cannot define these objects' motion as a whole by defining just single point. That's why in rotational motion of an object, the velocity of every single point is different. That's why you cannot treat this object when it is rotating as a point mass. You have to study every single point on this object individually. That's why describing the motion of one single point does not define the motion of other parts. So then, motion of every point must be described individually. So then this object must be treated as an extended object. Yani defining the motion of one point does not define the velocity or acceleration or other points. That's why this object cannot be treated as a point mass, and you should treat this object as an extended object. Basically, in rotational motion, you cannot treat an object. If the sentence is talking about rotational motion, you cannot treat an object as a point mass. So it must be treated as an extended object. So if rotational motion of an object is studied, the object must be treated as an extended object. 3 words: rotating, spinning, and one more word: rolling. So when a sentence is made with these 3 words, So, which means it's talking about the rotational motion of the object. The object must be treated as an extended object, rotating, spinning, and rolling. We have only one sectional question. In which of the following situations should the object be treated as a point mass? In which should the object be treated as an extended object? The first sentence. A baseball dropped from the roof of a house. So dropped. When you drop the baseball, this word is talking about as it's moving in translational motion. It's referring the motion of the center of mass. So a baseball dropped from the roof of a house. This must be treated as a point mass. But second one, a baseball rolling towards the third base. So when this is rolling, it refers to rotational motion of an object. So every point on this rolling object will move with different speeds. That's why you should treat this baseball when it's rolling as an extended object. C, pinwheel in the wind. So this is a pinwheel. So in the wind, this pinwheel is starting to spinning, starting to rotating. So then, which means this is also talking about referring to rotational motion of this object. So it also must be treated as an extended object. And last sentence, Earth traveling around the sun. So it is referring the circular motion of the Earth around the sun. So in this case, it's defining the motion of center of mass, defining the translational motion. So it must be treated as a point mass. So this is only question in your book, which if an object must be treated as a point mass or it must be treated as an extended object. And now an example in your book. Bowling ball hits the pins, and of course this pins motion is a little complicated because when the bowling ball strikes the pins, the complicated motion of each pin can be separated into two components. One component of the motion is translational motion. So pin is flying forward, but at the same time, this pin can spin in air too. So if you are studying the translational motion of the pin, you have to treat the pin as a point mass. But if you are studying the rotational motion of the pin spinning in air, so in this case, you have to treat the pin as extended object. This is one of the examples in your book. That's why I put it here. And sometimes they are taking the sentence, exact examples from the book and then making a question. Like, for example, they can ask a question like this. So a bowling ball strikes the pins and pin spins in air. So pin must be treated as A, point mass, B, extend object, C, none of them, D, blah, blah, blah. So if the word is made by spinning in the air, so it's referring to rotational motion, then pin must be treated as an extend object. But if they ask like this, when a bowling ball strikes the pins, so then the pins flies forward. So it's defining the translational motion. In this case, so A, pin must be treated as a point mass. B, must be treated as extended object. C, blah, blah, blah. D, blah, blah, blah. So then you are going to answer it as a point mass for flying forwards. How can you start to rotate the pin? Pin is spinning in air because bowling ball hits the pin. Now we will try to understand how we can start rotation of an object, but I'm going to make a connection to 11th grade. How can you start translational motion of an object? How can you start your car?
You obviously have to put force on it. So.
Yeah, without force, it's impossible. You should apply a force on an object to start or to stop. Also, you need to apply a force. Braking, for example. You brake your car. So the braking is also a force in the opposite direction. Acts and an object stops. So a force can start translational motion, or a force can stop translational motion. But rotational motion of an object starts with a torque. It starts with a torque. What is this torque? Torque produced by a force. Yes, there is a force. So force can start rotation on an object, but not always. So torque is produced by a force, but torque is not the same thing as the force. So a force can able to rotate an object. So we say that this force can produce a torque, but sometimes, or in some cases, force is unable to rotate an object. So we say there is no torque. So rotational motion starts with a torque, like translational motion starts with a force. Definition of the torque is given in your book with these sentences. Torque is a quantity that measures ability of a force to rotate an object. This is the definition of the torque. There must be a force, absolutely, but not enough. This force must be able to rotate the object. So, if a force is able to rotate an object, we say that this force produces a torque. But if a force is unable to rotate an object, which means this force cannot produce a torque. Now, we will see in which cases a force can produce a torque, in which cases a force cannot produce a torque, or in which cases a force can start rotation by producing torque, or in which cases a force cannot start rotation, so cannot produce a torque. Now, a force is able to rotate an object if it produces the torque. A force can produce a torque if, now condition, the force acts on the object at some perpendicular distance from the axis of rotation. Now, this is the figure. Here is an object. This can be a ruler. I'm going to show you a ruler now on my desk, but now I will first show on this big diagram. And this is the axis of rotation. Axis of rotation is the point object is fixed. If you push this object with this force, this force can rotate the ruler about this axis of rotation. Then we say that this force can rotate the object. That's why this force can produce a torque. Condition is what? The force must act at some perpendicular distance. Yani, look at here, it's perpendicular. At some perpendicular distance to axis of rotation. So this perpendicular distance is named as lever arm or moment arm. Yani, here, from force to axis of rotation, this distance is named as lever arm, or another name, moment arm. In this case, this ruler can turn. But a force is unable to rotate an object, yani it does not produce a torque, if the force acts on the object at its axis of rotation, or if it acts along the line, passes through the axis of rotation, like this. So this is the axis of rotation. Now you are pushing the object from its axis of rotation. This force cannot rotate the object. Or second force, F2. F2 is pushing this ruler, so its extension will pass through the axis of rotation. None of them, no F1, not F2, none of them can rotate this ruler. None of them can produce a torque. That's why we say F1 and F2 in here do not produce a torque, but F on the left side produces a torque and starts the rotation of the object. So I have a ruler in here. So I can fix this ruler. I'm going to fix this ruler from a point, and that fixed point in physics is called as axis of rotation. Now I'm going to fix from this point. This is axis of rotation. Then I am going to push this ruler with some force perpendicular distance at some distances. Now I am pushing it. Is ruler rotating?
Yes.
Is it rotating?
Yes.
So then this force, which I am my push, this force, my finger is pushing the ruler, is able to rotate this ruler. So then this force is producing a torque. But if I push it like this, now see it like this. Is it rotating?
No. No.
So if extension of the force passes through the axis of rotation, so force is unable to rotate the object. So my finger right now cannot rotate this ruler. This force, if I push it like this, in that direction, so when its extension is passing through the axis of rotation, this force cannot rotate the object. This force cannot produce a torque. Or if I push it in here, look at axis of rotation, this point is axis of rotation. If I push it in here, is it rotating?
No.
So if you apply a force at axis of rotation, or if you apply a force so that it is passing through the axis of rotation, these forces cannot rotate the object. That's why we say that these two forces cannot produce a torque. So these are the examples. Now I will continue screen sharing.
So teacher, the object doesn't rotate if there's no torque.
Yeah, yes, that's the point. Yeah, and rotation starts with a torque. If no torque, rotation does not start. So that's why this F1 and F2 in here. Can you see now the screen?
Yes, I can see.
So
Yeah.
in here, on the left side, this F is rotating the object. So this force can produce a torque. But F1 and F2, these two cannot rotate the ruler or the object because F1 is acting to axis of rotation. F2, its extension is passing to the axis of rotation. This is the rule. If a force acts on an object at axis of rotation or along the line passes through the axis of rotation, so then these two forces cannot produce a torque. These two forces cannot start the rotation of the object.
Teacher,
Yeah.
so can we say rotation starts by the force which produces a torque?
Yes, you are right. As rotation of an object starts by a force which can produce a torque. The perpendicular distance from the axis of rotation to a line along the direction of the force is called lever arm or moment arm. Now, what does it mean? I'm going to show on these pictures. This is the axis of rotation. This is axis of rotation. That is axis of rotation. I choose on the same ruler different points as axis of rotation. You can do that. You can fix the object from those points so that those points become axis of rotation. So in the first one, I am pushing the ruler from the tip with a force F. So according to this definition, the perpendicular distance from axis of rotation, yani you are going to draw a distance from axis of rotation to the line along the direction of the force. Draw a line along the direction of the force. This is a line along the direction of the force. And perpendicular distance from axis of rotation to this line is going to be the lever arm. So for the first picture, that distance is lever arm. But second one, I applied the force not at the edge, not to the tip, somewhere close to the middle. So in this case, perpendicular distance will be shorter than according to the first one if you compare. So this is the lever arm for the second picture. So distance, perpendicular distance from the axis of rotation to a line to a line drawn along the F is going to be this distance, lever arm. On the third one, I applied the force to the tip, but put the axis of rotation not at the edge, somewhere close to the middle. So this time, perpendicular distance from the axis of rotation to a line along the force is going to be this. This is the lever arm for the third picture. So this definition is important. They ask in ministry exam, they ask, generally they are giving the definition and asking what is this? Perpendicular distance from the axis of rotation to a line along the direction of force is called lever arm, or other name, moment arm. To produce a torque on an object, then, yes, absolutely, indefinitely, you need a force. You need a force. A force must act on an object. But this is not the enough condition. One more condition must be provided. But force must act over a lever arm. Then, if you multiply force by lever arm, you are going to calculate the torque. You are going to multiply the force by the lever arm, that perpendicular distance, and you will get how big torque is produced on this object. How big is the torque produced on this object? You can get it.